Okay, so for the next part of the problem, we're going to go through and find the eigenvector that's corresponding to -1. And again, keep in mind that's just us subtracting -1 off the main diagonal, which again is just going to increase our diagonal entries by 1. So we're going to have a 3 in the upper left corner, followed by the original two 4s that are there, followed by a 1. Again, that 2 is going to be bumped up to a 3, and then that number behind it is still a 3. And then the -3, the -4 stay the same. And then again, -5 is bumped up by 1, so now that becomes a -4. And again, we're going to take this matrix, do a row reduced echelon form. And when we do that with our graphing calculator, we end up with a 1, 0, 0. 0, 1, 1, and a 0, 0, 0. And again, we have that very important row of zeros there. And again, this is times some unknown vector v1, v2, and v3. That equals out to the 0 vector, 0, 0, 0. All right, so encoding this, the top row says that 1 times v1, well, that's equal to 0. That implies that v1 is equal to 0. The second row says that 1 v2 plus 1 v3 equals 0, so therefore v2 is the opposite of v3. Putting this back into component form, we've got a 0 in the v1 spot, a negative v3 in the second spot, and v3 is itself. So that corresponds to the vectors 0, -1, and +1. And again, that's for our lambda 1 equal to -1, the eigenvalue. So now we have to go in and find the complex eigenvectors corresponding to one of the values of lambda. So let's pick lambda is equal to +2i. So now we'll have to go in and subtract that number off of the main diagonal. So again, we've got the original matrix 2, 4, 4, 1, 2, 3, -3, -4, and -5. And now we're going to be subtracting 2i off of the main diagonal. Okay, and that's going to automatically introduce some interesting complex number calculations for us. So let's go through now and first of all go in and take that top number and multiply it by a conjugate. So we want to have a real number there. So the conjugate of 2 minus 2i we know is 2 plus 2i. We'll multiply that times the first row and put the result back here. So 2 minus 2i times 2 plus 2i is going to make a 2 times 2, which is a 4, minus a 4i squared, which will be an 8. So that turns into the number 8. And then we're going to have the 2 plus 2i multiplied to the 4s as well. So that's 8 plus 8i in both of those spots. And then we've got a 1, a 2 minus 2i, and a 3, and a -3, -4, and a -5 minus 2i. So for the next step of this, we'll go in and continue to do the row operations by hand on this 3 by 3 complex matrix.